Okay, so Pluto, that weird little dwarf planet way out on the edge of our solar system, is causing some buzz. Word on the street is it might run into Neptune. This has scientists and space geeks alike a little worried. Big-name experts like Neil deGrasse Tyson and Michio Kaku are talking about what could happen if these two have a cosmic collision. So, how did Pluto get on a collision course with Neptune? Well, Pluto used to be considered a real planet, but got downgraded because of its odd orbit. Even so, it still fascinates astronomers. People are saying that Pluto's path gets really close to Neptune's, and some worry they might crash, which could be bad news for Earth. Pluto takes a crazy long time, 248 years, to go around the Sun. Since it was but got downgraded because of its odd orbit. Even so, it still fascinates astronomers. People are saying that Pluto's path gets really close to Neptune's, and some worry they might crash, which could be bad news for Earth. Pluto takes a crazy long time, 248 years, to go around the Sun. Since it was found in 1930, it hasn't even made one full trip. Its orbit isn't like the other planets either. It's not very circular, and it's tilted at a weird angle compared to the other planets. Here's the strange thing. Pluto's path actually crosses Neptune's. For about 20 years of its orbit, Pluto is closer to the Sun than Neptune. So why haven't they bumped into each other? Other planets' gravity is the answer. Analyzing Pluto's orbit was hard for scientists. Unlike most planets, Pluto's orbit is tilted and off-center. And to top it off, it crosses Neptune's orbit. But Pluto's orbit is stable, which shows how complicated things are in space. The three-body problem helps figure out how Pluto, Neptune, and the Sun move and affect each other. Terms like IML libration and the Koisway help explain this cosmic puzzle. Astrophysicists think that libration, a kind of balance, keeps planets in their orbits. In the Pluto-Neptune system, it means that when Pluto crosses Neptune's orbit, it's always far enough away to avoid a crash. Libration makes sure Pluto is mostly above Neptune's path when it gets close. The Koisway explains why Pluto's orbit looks weird but stays in place. In the late 1980s, computer models showed that Pluto's orbit is actually chaotic, meaning small changes could cause big shifts over time. But Pluto's orbit stays pretty stable for a super long time. Scientists use computer tests to see how big planets like Neptune, Jupiter, and Saturn affect Pluto's path. Neptune and Pluto have a special relationship. Neptune orbits the Sun 3 times for every 2 orbits of Pluto. Jupiter's gravity also has a big pull, and Saturn's has a smaller one. Research proves that all these planets together keep Pluto moving safely in space for billions of years. These things are important for keeping things orderly in the solar system. Without them, things could get messy, with planets crashing or getting thrown out of the solar system, which would cause chaos. Understanding Pluto's orbit helps us understand if it might crash into Neptune. It shows how wild our solar system really is. Pluto shows us that even orbits that look unstable can be balanced with the help of gravity. We need to keep watching and studying these things to understand our place in the universe better. Exploring space shows us how strange planets can be, and Pluto's orbit is a good example. Orbital chaos shows how much a planet's path depends on where it starts. Even small changes in Pluto's position or speed could change its orbit a lot over time. Scientists use computer models to see how Pluto moves. By changing things a little in the models, they can see how small changes affect Pluto's path. These models showed that Pluto's orbit is chaotic, even though things like IML and libration keep it stable. Even a tiny change in Pluto's position or speed can cause big changes in its orbit over many years. But even with all this chaos, Pluto's orbit stays stable for billions of years. This means that even though it looks a little crazy, Pluto's path around the Sun is actually pretty organized. It's hard to guess what will happen to planets and predict their paths, especially with planets like Pluto that have weird orbits. We can't be sure about long-term predictions because these systems are so unpredictable. Math models help us understand and guess where planets will go, but they also show us that we can't predict everything. These models depend on knowing exactly where things start and showing crazy interactions. Even a small mistake can change the answers a lot, making it hard to guess right. Chaotic orbits like Pluto's remind us that the universe is always changing. We've learned a lot about space, but Pluto shows us we still have a lot to learn. Understanding how big planets affect Pluto's orbit teaches us about how the solar system works. It shows how each planet's place can change the stability and direction of other planets. Even with all these things, some smart people are worried about Pluto and Neptune colliding. Neil deGrasse Tyson, a famous astrophysicist, has some interesting ideas about our solar system, especially about Pluto. Tyson is the one who called Pluto a dwarf planet instead of a regular planet. He thinks our understanding of space is always growing. Tyson doesn't think Pluto's renaming was a bad thing, but that we just had to change things based on what we've learned. He thinks orbits like Pluto's show how much more there is to learn about space. Tyson thinks these mysteries make space science good. Tyson also knows that space events get people excited. He thinks Pluto's renaming and weird orbit are good ways to get people thinking and curious about the universe. By talking about the wild side of space, Tyson helps people understand and love space. Neil deGrasse Tyson helps the public wonder about the universe. He and other scientists are warning people about the possible problems with Pluto's orbit. After a lot of studying, he thinks the three-body problem could be a threat, and that a crash with Neptune might happen. Tyson says that this kind of crash could mess up the balance of the universe and even hurt Earth. A crash between Pluto and Neptune would be a very rare and terrible event. It would make a huge explosion, and Pluto would probably break apart because it's small and cold. Pieces of the crash could fly around the solar system, which could be dangerous for other planets and moons. The crash could change Neptune's air and orbit, depending on what happens. Michio Kaku, a famous theoretical physicist who works with string theory and talks about science, has some interesting ideas about this. He has thoughts on the future of space travel and how celestial mechanics and theoretical physics connect. He thinks studying Pluto and its orbit can show us about the future of space trips. Kaku says that understanding the gravity and orbits of planets like Pluto can help us with space trips. It can help us travel safer, plan for possible dangers, and plan trips to far places. Kaku thinks that we can use what we learn from Pluto's orbit to explore other places in space. Kaku often talks about how physics and planets connect. He thinks that the movements of planets, like Pluto and Neptune, are tied to basic physics. Kaku's work in string theory tries to understand these rules. He thinks that studying Pluto's orbit can give us ideas about the basic rules of the universe. Like Tyson, Kaku has talked about a possible crash, relating it to his ideas about the cosmos. If Pluto and Neptune crashed, it would be a big deal in astronomy. Such an event could offer insights into the behavior of fundamental particles and forces under extreme circumstances and help us test parts of string theory. String theory is a theoretical framework that seeks to describe the fundamental forces in the universe. While it wouldn't hurt Earth because we're far away, it could teach us a lot about the universe. Pluto's orbit is a good example of celestial mechanics, showing space is both stable and chaotic. The special parts of its orbit, changed by the gravity of other planets like Neptune, show how wild and changing space is. The universe has mysteries, and the three-body problem is one of them. Scientists anticipate other possible catastrophes. While crashes are not likely, they are possible. The way gravity shapes planet orbits, including the three-body problem, can make them unstable in some systems like TRAPPIST-1. Researchers keep an eye on these systems to see how planets affect each other, especially when they are close. This shows how planets move in space. There's also a curious thing called rogue planets. These planets used to be part of a star system, but got kicked out by gravitational disturbances or other cosmic occasions. If one of these rogue planets enters solar system, there is a slight chance of a collision with a planet in that system. These renegade planets could crash into another system. However, they don't really impact other planets because everything in space is so far apart and rogue planets are relatively rare. When they figured out Pluto's orbit, it was a puzzle for scientists. Unlike most planets, Pluto's orbit is tilted and weirdly shaped. And then they realized it crosses Neptune's path. But Pluto's orbit stays stable, which shows how complicated space stuff can be. The thing is, figuring out how three things in space move around and pull on each other, like Pluto, Neptune, and the Sun, is super hard. But it seems like there's some kind of balance that keeps Pluto from crashing into Neptune. When Pluto crosses Neptune's orbit, it's always far enough away to avoid a collision. Also, Pluto's orbit looks random, but it's actually pretty steady. Back in the 1980s, computer models showed that Pluto's orbit is actually kind of chaotic, meaning small changes could cause big problems over millions of years. But so far, it's been stable for a really long time. Scientists are still running tests to see how planets like Neptune, Jupiter, and Saturn mess with Pluto's path. Neptune and Pluto have a weird relationship. Neptune goes around the Sun 3 times for every 2 times Pluto does. Jupiter's gravity also has a big pull, and Saturn's has a smaller but still important pull. All these things together keep Pluto from going haywire for billions of years. Without these forces, the solar system would be a mess, with planets crashing into each other or getting thrown out of orbit. So, understanding Pluto's orbit helps us figure out if it might hit Neptune someday. It also shows how crazy but stable things can get in space. We need to keep watching and studying this stuff to better understand our place in the universe. Space is weird, and Pluto's orbit is a perfect example. Even a tiny change in where Pluto is or how fast it's going could totally change its path in the long run. Those computer models from the 80s helped scientists see that even though things like IML and vibration keep Pluto stable, its orbit can still be unpredictable. But even with that chaos, Pluto's orbit has stayed stable for billions of years. It's like there's a hidden order to it all. Trying to guess what's going to happen in space, especially with planets like Pluto that have weird orbits, is really tough. These systems are just naturally unpredictable. Mathematical models can help us guess, but they also show us how much we can't know. Even a tiny mistake in the starting information can lead to totally wrong predictions. The fact that orbits like Pluto's are chaotic reminds us that the universe is always changing. We've learned a lot about space, but Pluto shows us how much more we still need to figure out. Understanding how the big planets mess with Pluto's orbit helps us understand how the whole solar system works. It shows how each planet's position can affect the others. Even with all these forces, some scientists are still worried about Pluto and Neptune hitting each other. Neil deGrasse Tyson, that famous space guy, has some interesting thoughts about Pluto. He's the one who said Pluto wasn't a real planet anymore. He thinks our understanding of space is always changing. Tyson doesn't see Pluto's demotion as a bad thing. He just thinks we had to change our minds as we learned more. He thinks the weirdness of orbits like Pluto's shows how much more there is to learn. Tyson also knows that people get excited about space stuff. He thinks things like Pluto's demotion and its crazy orbit are chances to get people interested in space and the universe. By talking about the weirdness of space, Tyson hopes to get people more excited about it. Tyson, along with other scientists, is warning people about the possible dangers of Pluto's orbit. He's worried that the three-body problem could cause a crash with Neptune, which he thinks is overdue. He also says that a crash like that could mess up the balance of the universe and even have bad consequences for Earth. A Pluto-Neptune crash would be a huge deal. It would release a ton of energy and probably break Pluto apart since it's smaller and colder. The pieces would spread all over the solar system and could be dangerous to other planets. Neptune's atmosphere and orbit could also get messed up. Michio Kaku, a smart guy who studies string theory, has another take on all this. He has some deep ideas about space exploration and how planet movements connect to physics. Kaku thinks that studying Pluto and its orbit can help us with future space missions. Understanding how gravity works and how planets move can help us travel around the solar system better, avoid dangers, and plan trips to far-off places. The lessons we learn from Pluto could help us explore other planets in the future. Kaku often talks about how planet movements and physics are connected. He thinks that the way planets move and pull on each other, like Pluto and Neptune, isn't just random. It's connected to basic laws of physics. Kaku's work in string theory tries to understand these rules at the deepest level. He thinks looking at crazy planet movements like Pluto's can give us hints about these rules. Like Tyson, Kaku has also talked about a possible collision. He says it would be a huge opportunity for scientists and could teach us about string theory. String theory tries to explain the basic forces and matter in the universe. A big crash in the solar system would create extreme conditions that could help us test string theory's ideas about gravity and spacetime. Even though a Pluto-Neptune crash wouldn't directly hurt Earth because we're so far away, it could still be a big deal for science. It could help us understand the universe better, according to string theory and other ideas in physics. Pluto's orbit is a great example of how space can be both stable and chaotic. Its weird orbit, which is affected by Neptune and other planets, shows how complicated and ever-changing space is. The universe is full of mysteries, and the three-body problem is just one of them. There are other possible disasters that scientists are thinking about. It's not very likely that planets will hit each other, but it's not impossible. The three-body problem explains how gravity affects planet orbits. In some systems, like TRAPPIST-1, which has 7 Earth-sized planets, gravity creates patterns that can make planet paths less stable and lead to crashes. Even though systems like TRAPPIST-1 are crowded, crashes aren't happening right now. Scientists are watching these systems to see how planets affect each other, especially when they're close together. This helps us understand how planets move in space. Another weird thing is maverick planets, planets that drift through space without orbiting a star. These planets used to be part of a star system, but they got kicked out because of gravity or other events. They can travel huge distances and might run into another star system. If a rogue planet enters another solar system, there's a small chance it could hit a planet in that system. But space is so big and empty that it's not very likely. There's just too much space between things for crashes to happen often. Plus, rogue planets are pretty rare compared to planets in stable orbits, which makes crashes even less likely.